Hello my dear students! Welcome back to my YouTube channel. This is me once again, Teacher Tin, your science teacher for today's video. So, ngayon pag-uusapan naman natin ang tungkol sa quantum mechanical model, which is the first topic in your grade 9, Science 9, and ito na nga, tungkol to sa chemistry. So, halika na at samahan ako sa ating lesson vlog na ito. And, of course, if you're new to this channel, don't forget to subscribe, like, and hit the notification bell for more updates in Science 9. At the beginning of the 20th century, a new field of study known as the quantum mechanical model has emerged. At kung kilala nyo at natatandaan nyo si Niels Bohr, ito siya. Okay, siya ay isa sa founder ng tinatawag nating quantum mechanical model. At siya yung nag-explain ng discrete line spectrum observed when light was emitted by different elements. And of course, si Niels Bohr, kung natatandaan nyo, interesado rin siya sa structure ng atom, which is napag-aralan natin nung kayo ay nasa grade 8 pa lamang. Okay, so, nung panahong ito, medyo parang naging debate ito nung panahong yon. So, napakadaming models ng atom ang lumabas, and there are different, yan na nga sinasabi ko sa inyo, there are numerous models of the atom that has been postulated based on the experimental results, including the discovery of electron, kung natatandaan nyo si J.J. Thomson. Yan. And syempre, kung meron tayong discovery ng electron, meron din tayong discovery ng nucleus, which is na-discovered naman, nino nga? Yan, na-discovered naman ni Ernest Rutherford. Yan. Okay, so, kung naaalala nyo nung grade 8 tayo, may pinag-aralan tayo tungkol sa structure ng atom. At ito na ngang si Niels Bohr, sinuportahan niya yung tinatawag na planetary model. So, kaya siya tinawag na planetary model kasi para siyang solar system. So, inihalin tulad ni Niels Bohr ang structure ng atom sa solar system, which is, meron siyang, which is yung electrons is nagre-revolve siya around positively charged nucleus like the rings around Saturn, or alternatively, the planets around the Sun. In this lesson, you will learn that the quantum mechanical model of the atom describes the energies and, of course, the position of the electrons. So, in particular, we will also develop a picture of electron arrangements in atoms, a picture that allows us to account for the chemistry of various elements. So, bago yun, syempre, kailangang reviewin muna natin yung kay Niels Bohr na planetary model. Okay? Okay, ano nga ba ang meron sa Bohr model of an atom? So, if you can still remember, in 1911, at the age of 25, imagine that, 25 years old lang, but Niels Bohr's already received his PhD. So, PhD, it means Doctor of Philosophy in Physics. Napakahusay ni Niels Bohr. So, he was convinced that the atom could be a picture as a small positive nucleus with electrons orbiting it. Okay, or orbiting around it. So, kaya naman, kinumpare ni Niels Bohr ang structure of an atom sa isang solar system. Dahil ano bang meron sa solar system? Diba, kay yung sun, nasa gitna, and then, umiikot dito yung mga planets. So, dito naman sa structure ng atom, so, kinumpare ni Niels Bohr yung structure ng atom sa planetary model or sa solar system dahil nga sa kanya, okay, yung mga electrons ay umiikot sa paligid ng nucleus at saka ng proton. Okay, now, over the next 2 years, so si Bohr, kinonstruct naman niya yung model ng hydrogen atom with quantized energy levels. So, in this case, si Bohr, pinicture niya yung electron moving in a circular orbits, kagaya nga nung ina-explain natin kanina pa, corresponding to the various allowed energy levels. So, sinadjust niya na yung mga electron ay pwedeng tumalon sa iba't ibang orbit. So, kung mapapansin nyo, di ba, ayan, kung makikita nyo, maraming mga orbits dyan, parang yung solar system. So, ibig sabihin ni Niels Bohr, may mga electrons down na pwede siyang mag-jump into other level by absorbing or emitting photon of light with exactly the correct energy content. Ano ibig sabihin yan? Malalaman din natin yan sa mga susunod pa nating discussion. Well, at first, Bohr's model appeared very promising. So, parang very perfect yung unang gawa niya. It fit the hydrogen atom very well. However, okay, nung yung model na to ay in-apply na sa atoms ng ibang hydrogen, other than hydrogen, kasi nung sa hydrogen, okay daw fitted well kumbaga. Pero nung in-apply na itong model na to sa ibang atoms na hindi na hydrogen, parang hindi na siya nag-work. So, kaya naman, in fact, further experiments show that the Bohr's model is fundamentally incorrect. So, anong nangyari dito? So, although the Bohr model paved the way for other theories, it is important to realize that the current theory of atomic structure is not the same as the Bohr model. Okay, now, so let us proceed with the discussion about the wave mechanical model of an atom. So, noong kalagitnaan ng 1920s, of course, apparently, yung discovery ni Niels Bohr, or yung Bohr's model was incorrect. The reason why there are scientists who still pursue to discover new approach in atom. So, there are two young physicists, si Louis Victor de Broglie from France and Erwin Schrödinger from Austria. They suggested that because light seems to have both wave and particle characteristics, wherein it behaves simultaneously as wave and a stream of particle. So, parang sa kanila, the electron might also exhibit both of these characteristics. Kaya naman, although maraming tao yung nag-assume na ng electron was a tiny particle, so this scientist said that it might be useful to find out kung saan nga ba at kung paano nga ba na pwedeng i-describe ito as a wave. When Schrödinger carried out a mathematical analysis based on this idea, nalaman niya at na-discover niya na yun palang na-discover niya na itong new model for the hydrogen atom is also suited to other models or to other atoms, which is dun nag-fail si Bohr. Kasi yung kay Bohr, di ba, suited lang ito or fitted well lang ito sa hydrogen atom, pero sa ibang atom hindi na. Pero si Schrödinger, using his mathematical analysis based on this idea, so fitted well also siya sa ibang atom. Kaya naman, we will now know and we will now explore a general picture of this model, and this is what we call the wave mechanical model. Okay, di ba sa Bohr's model, ina-assume nila na yung electron daw ay nag-move in circular orbits. But in wave mechanical model, on the other hand, so in-introduce ito ng mathematical description of electron's motion called wave function or atomic orbital. Orbitals are nothing like orbits. Squaring the orbital gives the volume of space in which the probability of finding the electron is high. The electron cloud or the electron density. The model in this figure gives no information about when the electron occupies a certain point in space or how it moves. In fact, we have good reasons to believe that we can never know the details of electron motion. But one thing we feel confident about is that the electron does not orbit the nucleus in circles as Bohr suggested. Okay class, so may tinatawag tayong Schrödinger's equation. So sa Schrödinger's equation, nire-require ito na gumamit ng quantum numbers para ma-describe yung bawat electron within an atom corresponding to the orbital size, shape, orientation in space. Now, later it was found out that one needed a quantum number associated with the electron spin. At yan ang pag-uusapan natin sa kasunod. Okay, now, let us discuss the different quantum numbers and orbitals. So, meron tayong 4 na quantum numbers. So, the first quantum number, which is the principal quantum number, which is symbolized letter N. So, it describes the size and energy of the orbital and relative distance from the nucleus. Okay, so again, so principal quantum number, letter N ang ating symbol diyan. So, ang possible values ng principal quantum numbers ay 1, 2, 3, 4, and so on. So, they are positive integers. So, ano ibig sabihin nito? So, the smaller the integer or the smaller the value of n, so kung 1, ibig sabihin, mas lower yung energy niya at syempre, mas closer siya sa nucleus. So, habang tumataas yung kanyang principal quantum number, ibig sabihin, lumalayo siya sa nucleus. Okay, so sometimes, nire-refer din natin yung principal quantum number as designating the shell the electron is occupying. So, and of course, each shell contains one or more subshells and each with one or more orbitals. Okay, nabanggit na natin yung orbitals. Ano ba yung orbitals? So, meron tayong 4 na orbitals. Meron tayong s orbital, the p orbital, the d orbital, and of course, the f orbital. So, s, p, d, f. Ngayon, so sabi nga natin, each shell contains one or more subshells with each with one or more orbitals. So, the second quantum number, kanina ang first ay principal quantum number. So, ang pangalawang quantum number ay tinatawag natin na, the second one is the angular momentum quantum number or letter L naman po ito. So, ano meron dito? It describes the shape of the orbitals. Okay, class. So, sa angular quantum or sa angular momentum quantum number or yung L na nga, so, since dinidescribe nito yung shape ng orbitals, so yung value nito is related sa principal quantum number. And inaalaw dito yung value na 0. So, 0 to n minus 1. So, for example, if n is 4, okay, so then the possible values of L could be 0, 1, 2, and 3. Okay, so ito yung mga kailangan nating tandaan when it comes to the orbital. So, kapag ang L or ang angular momentum quantum number L is 0, so ibig sabihin, ito ay tinatawag natin na S orbital. S orbital. So, ibig sabihin, ang kanyang, meron siyang spherical shape with the nucleus and it is at the center of the sphere. So, lagi natin tatandaan na the greater the value of n, of course, is the larger is the sphere. So, kung idodrawing natin ang S orbital, so, parang bilog lang siya. Yan. So, ito yung S orbital and ang S orbital, ang S orbital, so, ang S, ang ibig sabihin ng S is sharp. Okay, sharp and it has spherical shape. Okay? So, yan po ang ating S orbital. Tatandaan nyo ha, pag L is 0, ibig sabihin S orbital. Paano naman kapag ang L is 1? L is 1, so ang tawag naman natin dyan is P orbital. P orbital. Okay? So, sa P orbital, ang shape naman po niyan is yan, parang paganan. So, yung P, ang tawag natin dyan ay, kaya siya tinawag na P kasi P stands for principal. Okay. So, kung mapapansin nyo, ang kanyang shape ay ganito, dalawang parang siyang, kumaga parang may 2 lobes. Ano? So, sa P orbital or principal orbital, kung ang ating angular momentum is 1, so meron tayong 2 lobes of high electron density. Now, and then of course, as you can see, so ito nga ay 2 lobes of high electron density on either side of the nucleus for an hourglass or dumbbell shape. So, para siyang dumbbell shape, di ba? Na parang, ano yun? Siya, nakita naman yung hourglass. Ayan, parang nakahiga lang siya na hourglass. So, now, paano naman kapag ang ating L is 2? So, ang tawag na natin dyan ay D orbital. Okay, ito naman, meron na siyang variety of shapes. At yung D, it stands for diffuse. Okay? And D orbital has 4 lobes. So, paano natin i-drawing yun? So, kung meron siyang 4 lobes, so ganito na ang itsura niyan. Yan. Parang bulaklak, di ba? Okay, so again, if the angular momentum quantum number is 2, it is d orbital. D stands for diffuse, and ang shape niyan is, okay, has 4 lobes with a variety of shapes. So now, paano naman yung last? Yung 3. And ibig sabihin, siya naman po ay F orbital. Okay, F orbital with more complex shapes. And as you can see, ang F, ang ibig sabihin natin ng F is fundamental. At pag idodrawing na natin ang F orbital, so complex na yan. So parang may paganyan. Yan. Tapos, meron pa ulit dun. Okay, so ayan. Yan. Kumaga parang pag dirinawing mo yung isang box. So, meron siya sa bawat sulok na nakaganito. Dun sa bawat sulok. Okay, again, sa ating angular momentum quantum number, if L is 0, that is S orbital and has spherical shape. If L is 1, that's P orbital and it has 2 lobes. If L is 2, that's D orbital and as you can see, it has a variety of shapes. And if L is 3, that's F orbital, which is with more complex shapes. So S stands for sharp, P for principal, D for diffuse, and F for fundamental. Okay, next. The third quantum number is what we call the magnetic quantum number or ML. So M with the subscript na L. So it describes the orientation of the orbital sound around the nucleus. Okay, so sa magnetic quantum number, so kapag ang kanyang, pag pumatak na ang angular momentum quantum number is 3, so ang magnetic quantum number niyan, pwedeng ang pumatak naman ay -3, -2, -1, 0, +1, +2, or +3. If the angular momentum quantum number is 1, so ang possible magnetic quantum number niyan is pwedeng -1, 0, or +1. So, paano kapag ang L is 2? Of course, ang pwedeng maging magnetic quantum number niyan is -2, -1, 0, +1, and +2. Nagagets nyo? Okay, maaaring medyo nalilito pa kayo sa part na to, pero pag in-applyan na natin siya mamaya, maintindihan nyo na kung para saan itong mga sinasabi nating quantum numbers. Okay, now, let's proceed with the fourth quantum number, which is the spin quantum number. Okay, so for the last quantum number, we have the spin quantum number. So, ito naman ay MS. Okay? So, it indicates the direction of the electron is spinning. Saan ba siya umiikot? Okay, class. So, sa spin quantum number, there are only two possible answer for that. So, the two possible values ay pwede siyang +1/2 or it can also be -1/2. So, kapag yung dalawang electrons ay nag-occupy ng same orbital, so yung isa must have an spin quantum number of +1/2 and the other one or the other electron must have -1/2. At these are spin paired electron. Ayan, parang mali ang spelling. Okay, ano hindi maintindihan? Spin paired electron. So, yun yung tawag kapag yung dalawang electrons ay nag-occupy ng same orbital. Sige nga, tingnan nga natin kung makakasagot kayo dito. So, let us have this. If n is 7 or if the principal quantum number is 7, what are the possible values of L? Okay, so L, that's the angular momentum quantum number. So, di ba sabi natin para ma-detect natin kung ano yung mga values ng L in relation to the principal quantum number, it is always n-1. So, n-1, so ibig sabihin, ang value ng n is 7. So, 7 minus 1, that's 6. And lagi tayong may 0. So, ibig sabihin, so if n is 7, so the possible values of L will be 0 until 6. So, L, it can be 0, 1, 2, 3, 4, 5, 6. Okay? So, ganun lang. Lagi lang kayong n minus 1. Kung anong value ng n, ima-minus nyo lang sa 1, tapos magdadagdag kayo ng 0. So, yung mga values niyan, pwedeng pumatak ng 0, 1, 2, 3, 4, 5, 6. Okay? Next question. So, if n is 3, and L is 2, so tama naman, papatak na 2 kasi n minus 1, that's 2. So, ang possible L is 0, 1, 2. And kung yung L daw or yung angular momentum quantum number is 2, then what are the possible values of ML or the magnetic quantum number? So, dito na tayo magbe-base sa 2. So, di ba kapag magnetic quantum number, ang tinitingnan lang natin ay positive numbers and negative numbers. So, kung 2 yan, so magsisimula tayo sa ML, it can be negative 2, negative 1, 0, positive 1, and positive 2. So, ito lang ang mga posibleng sagot dyan kung ang ating angular momentum quantum number is 2. Okay? Yan! Very good. Okay, thank you for listening. Hanggang dito na lang ang ating part 1 ng ating module 1 week 1. So, in our next discussion, we're going to discuss about the electron configuration. Yan, at yun yung part 2 ng ating week 1 module 1. So, stay tuned on this channel and let us discuss the next topic in chemistry. So, this is me once again, Teacher Tim, your science teacher for today's vlog. If you're new to this channel, don't forget to subscribe, like, and hit the notification bell for more updates in Science 9. I hope to see you soon. Bye!